So let's do a quick exercise to summarize what we do in each of the three cases that we've discussed in our previous videos for partial fraction decomposition. In this exercise, we're asked to set up a partial fraction decomposition for this rational expression, a rather complicated one. So it just says set up. It doesn't say to actually finish the problem and find the partial fraction decomposition. And what is meant by this is you need to set it up in the correct format, but you don't necessarily need to find the value of A, B, and C, and whatever those constants happen to be. So we're just trying to get a correct format for the decomposition. Now, we have numerous factors in the denominator, which arise in several different forms. The happiest of all of these is the factor x minus 2, who occurs with degree 1 because it is linear, and multiplicity 1 because it doesn't have any exponent. And in that case, we can put a single copy of x minus 2 down. Since this has degree 1, we can put a degree 0 quantity in the numerator, a constant. Now this brings us to x plus 5. X plus 5 is a degree 1 factor, still linear, but it has a multiplicity of 3, that exponent of 3. So what we'll need to do is do 1, 2, 3 factors for x plus 5. X plus 5 with no exponent, or I should say with an exponent of 1, over a degree 0 term, b. Then x plus 5 with the next multiplicity, x plus 5 to the second power, to a degree 0 numerator. And then finally, x plus 5 to the third power, degree 0 numerator. So multiplicity 3 requires 1, 2, 3 fractions for the exponents 1, 2, 3, counting up to the multiplicity. Now finally, we have this fraction here, x squared plus 5, an irreducible quadratic, degree 2. And since it is of degree 2, we'll need to put a generic degree 1 expression in the numerator. So we'll need to put something that's linear in the numerator, e times x plus f. So this would be the template that I would use to decompose this complicated rational expression into a sum of much simpler rational expressions based on what I should do in each of the three different cases for my partial fraction decomposition.